Okay, here we go. Now we're going to do an example for Shop Job 1201, and we're going to start with Shop Job 1101 in our programming software and modify that. What we're eliminating here is the two position selector switch, but in its place we're adding the third normally open push button, which is the yellow push button. Everything else pretty much remains the same. So we're going to come back over to our Shop Job 1101 and we're just going to modify this. Okay, so we want to first of all save this as our next shop job. Okay, and we want to modify this to also denote the proper shop job. Okay, and we're not going to have this here anymore. Okay, so we have our start stop station like we had for 901 right here, correct? So that is what we need if we push the start button, is what by definition over here is what we need when you read the description. We need, if we have the green button pushed, it's going to be a normal stop start station. What we need now is this yellow push button to actually be a jog function. Okay, so we're going to come back over here, and this is where we're going to actually get into the use of binaries. So there's a whole video on binaries that you can watch. And basically what a binary address is an address that's just held in memory. It's not tied to an input or an output. And we're going to start to use those in this job. So we're going to take this first shop job here. We're going to replace this output with a binary, and I'm just going to use B30/0. It's the very first binary, and I'm going to call this run command. Okay, and RUNCMD. Okay, so that's going to be our binary that we are going to write to, and we're going to use that later on in the program. Okay, and just like we did with the actual output, we want to make sure that we're the ones that in this rung is energizing it. So we're going to have that run command down here. So now we've replicated what we had for 901, except we just replaced our output file, our output address, with our binary address. And the reason we're doing that is because multiple rungs are going to be able to turn on one output, and we only want to have that output address in the PLC one time. Okay, if you just highlight the rung and hit Control-C, you put this entire rung into a paste buffer. If I hit Control-V, that is going to paste it just below it. Okay, so we don't need the comment, so I'm just going to clear out our comment. It's going to say, hey, do you want to delete that out of the database? And you say yes. And what's the difference between a rung that is a start and holding circuit versus one that's a jog circuit? Well, we don't have this holding rung at all. Okay, so this is going to end up to be our jog function down here. Of course, our jog push button is different from our start push button, and we can come over here and look in our PLC assignments, and our yellow push button is going to be input 0.0/6. Okay, so I'm going to change this to a 6, and I want to actually give that a description and a symbol, and this is going to be jog motor, and just put jog here. Okay, so now, of course, if we push the stop button, we don't want to be able to jog, and in the off chance that somebody's holding down the stop button, we don't want to be able to hit the jog button and get it to jog. And now this is our run command. We don't want to write to over the top of this run command, so I'm just going to pick the next address down, and we're going to use it, and this is going to be our jog command. Okay, and JOGCMD. Okay. Okay, so now we have a decision here to run stored up in this binary, and a decision here to jog stored up in that binary. So now we can just use those at the rung below here to actually write to our outputs. Okay, so our output in this case is going to be CR1 still, right? And that's the benefit of having a symbol, is I don't have to type in the address. Once we have it symbolized, I can type in the symbol like I would type in the address, and it finds it for me. Okay, so now what are the two things that can turn this motor on? It can be turned on by either being commanded to run, like that, or it could be turned on by being commanded to jog. And notice I'm using the word or. If I command it to run or I command it to jog, and I could just go ahead and type in the symbol here, jog command. So if I command it to run or I command it to jog, I will actually start the motor. And if I start the motor, then those will close. And if I commanded it in the run function, it will stay running. But if I command it in the jog function, see, these will close, but I hadn't commanded it to run. I would have to have B301 up here. It's not going to hold that in. So that's another benefit to having that in that holding circuit. Okay. Now let's check our job sheet here to see how we want the blue light to behave. When the motor is running in jog, the green and blue light shall illuminate. Okay, so last time it was if we selected jog. Now it's if we're running in jog. Okay, so we want to come back over here, and we have our blue light implementation right here, but we no longer have this selector switch here. So what two things tell us that we are in jog? Well, we have our jog command and we have our status that's come back from our relay. So this would be our jog underscore CMD. That tells us that we're trying to jog it, and then this would be our status, which is I:0.0/7. Okay, the CR1 status. So if we're commanding it to jog and that status contacts close, we're going to show the blue light on. Okay, my program's getting kind of big. It's bigger than what we can show on one display, so I'll just have to scroll up and down for us. We'll go ahead and download this. Okay, so now we have the e-stop and stop are both closed, so we're good there. I'm going to go ahead and push the start button. We'll energize this binary. When we energize that binary down here, since that closes, we're going to energize our relay. When our relay gets energized, those will close, and this is already on because we turned it on. And we'll have a holding circuit here. So I'm going to go ahead and hit the the start push button. And if you notice, we have a green light here, we have our LED there, and you can see in the program that we have a holding circuit. I'm going to hit stop. Now I'm going to push the jog button. If you notice, there's going to be a couple things that's going to happen here. This is going to be energized. When that gets evaluated to true, this part of our parallel circuit will become true. And since this is an OR statement, if either that or this are energized, we're going to energize that output. We will turn the motor on. We're also going to notice that these sets of contacts are going to close, but since we did not tell it to run, that will evaluate to false, and we won't hold the motor on, and we're just going to be in a jog function. So I'm going to push this lower one. This would normally be our green push button, and that would normally be our yellow push button. Okay, so you can see right here that that is not evaluating to true, and because it's not evaluating to true, we're not keeping the motor running. And let's look at our blue light implementation down here. Okay, so when I push on the button, I'm turning on that binary to to jog the motor, and when the motor contacts actually close, the blue light comes on. Okay. Before, when I push the start button here, if you notice, the contacts pulled in, but I didn't expressly tell it to jog. I told it to run instead. That's what this little input here is telling us, this run command. So the blue light did not come on. Okay, so there again, the blue light is telling the operator what's actually happening with the motor when you release that button. Okay, so that is our shop job 1201. I hope that helps, and we'll see you in the next video.